So today we have the Beckman Coulter Access to Analyzer that we use to run our troponin results on. So I'm just going to show you the analyzer overview, how we place the sample on, show you the inside and how everything works together, and our result. So we're going to start by explaining the principle behind how the instrument works. So, as I stated before, immunoassays, and therefore this machine uses an antibody reagent in order to detect the antigen of interest, and it uses a mono or polyspecific reagent. So therefore, once again, we're looking for the TNI antigen and detecting our troponin levels. Okay, so purpose. So right here, this is the access wash that's used to clean, dilute if needed. This is the empty waste container, and this is the substrate which is used in order for the reaction to take place. So if I open up this compartment here, this compartment contains our waste bag, in which all the used reaction vessels, which look like this, and contain this much substrate in. This is where the reaction takes place at. And the substrate inside is actually chemiluminescence. So therefore, it works by, as more antibody antigen complexes are being made, it measures the decreased light intensity that goes through here. So the absorbance. The concentration is directly related to the light that is measured by the instrument that detects how high or low the antigen concentration is for troponin. Okay, so now we're going to open it up. So this is all still connected through here, and with this being open, you'd be able to see that, but it's a lot of hassle. So therefore, over here is our main aspirator probe, and this is what pulls up the sample from our patient's tubes. Over here, we have our substrate probe and our fluid modules that do everything else. So the substrate probe specifically pulls the substrate to add it to the reaction vessel, in which we've seen in this part, for it to then be added with our patient sample. The rest of these fluid probes are used to add the reagents, the washer buffer if dilution is needed, to dispense and remove the liquid waste into our waste container after everything is done. So that's how this part works. Okay, so now that I've showed you the principle behind the instrumentation and the parts of it, I'm going to show you now how to run a patient sample. Now, before we run a patient sample, we must always have to make sure that our QC is okay. So QC is ran once a day and is good for 24 hours, and we preferably do it here at night. So before we do our QC, we prime the substrate to ensure that an accurate level of substrate is coming out every time, and then we also run it clean to ensure that there's no blockage, no salt buildup or anything of that in our aspiration probes, to make sure that samples aren't contaminated, and then once again that an accurate level of reagent, patient sample, wash if needed, is properly coming in and properly going back out. So this right here is our patient sample, and as you can see, there's no bubbles, there's no clots, and it is a good yellow regular plasma color. So depending on what kind of tube we have, depends on what kind of rack we use. We do not have the 13 by 100, we have the 13 by 75, so this is the rack we're going to use. We're going to place our sample in the rack, make sure the barcode is facing forward. We're going to open this door. Now here, these are where the reagents are stored. And here we go, right up top, our troponin I reagent. So now we're going to put the sample in here, make sure that our barcode is facing out forward. So we're going to push loader rack, done, and run. So now it is going to take this rack and it is going to spin and check it and scan it to see what test it is that we're going to perform. Once it comes back, it's going to read up here what test we need. That says requested, and then it's going to show our aspiration time and our completion time. At this point, it has registered that we've chosen troponin, and it's going to take 19 minutes for our sample to run. So we'll do that. As we talked about before, we're looking for TNI antigen on red cells in order to detect anything cardiovascular, myocardial specific. So therefore, any sample that has hemolyzation or looks close to this or clotted would not be something we want to use. Clotted samples could cause false positives, as we're looking for antigen immunocomplexes, correct? And hemolysis could falsely decrease our results since we're not having as many red blood cells present anymore. So when we have our correct sample and our patient is within normal range, then we'll come here and we will see the result as a 2.7, which will then be accepted by our LIS system and transfer over to our computer. So now we're reporting out the patient sample. So our result came out as a 2.7, this first one. So therefore, our troponin values here, our reference range 0 to 12 for females is within normal range, and for males 0 to 20. If they were to be outside of this, then we would report them as critical values, and it would flag on our LIS system, and then we would have to call and report it to the doctor in conjunction to what the patient's current condition is, to ensure that the result that we have makes sense to the current situation of the patient. If the doctor confirms that the patient condition matches our suspected result, then we are allowed to release the result with a comment confirmed by the doctor. If our sample just so happens to go over 2,700, then it automatically dilutes. But the thing is though, the instrument may register it as contaminated because it's so high. So therefore, QC must be ran again to ensure that the sample itself is actually that high, no contamination was seen, and that everything was run correctly, and that our instrument runs accurately and precise. So there you have it. That is how our Beckman Coulter Access 2 monitors, finds, and reports out our antigen for troponin results.